Alrighty guys, Sasquatch Prospector here for you. So if you look on the screen, that's the Trinity test explosion from one of the atomic bombs they were testing. So this is going to be a big one, guys. We're talking about the secret nuclear program in Canada that took place in Trail at the fertilizer plant to produce heavy water using electrolysis. Now, the same thing was going on in occupied Norway at the time by the Nazis. The Nazis had seized the Norsk hydro dam in the Telemark region of Norway, and we're using the power from the dam to conduct electrolysis extraction of heavy water to potentially produce an atomic weapon that Germany could use in the war. At the same time, the United States had the Manhattan Project, Robert Oppenheimer, and they were trying to produce their own atomic weapon. So this is the story of Project 9, the secret heavy water production project that took place in Canada that aided in nuclear research technology that eventually allowed America to create a nuclear weapon. There's a lot of history here. A lot of it has not been covered much at all, really. So guys, this is going to be a big one. Buckle your seatbelts. Project 9, the Canadian Manhattan Project, heavy water production, atomic weapon.
This is really interesting because this is the first man-made isotope. It was underneath the atomic bomb, and when it fused the sand to glass, and that's fused to glass. So it's the
That's
first,
incredible. First man-made isotope.
Yeah.
Trinitite.
It's called trinitite.
Trinitite, yeah.
From Trinity site for the bomb.
Oh, from the bomb.
Yeah. It's radioactive, so it has to be kept in the plastic.
Oh, that's why it's in the
I
plastic.
use it for birth control.
We are headed to Warfield now, the site of the Canadian Manhattan Project. There's a lot to this, guys. So back in 1942, there was a secret race going on between the Nazis and the Allies for who could create an atomic weapon first. The Nazis had taken this hydro dam in the Telemark region of Norway, which was the only other facility in the world capable of producing heavy water at the time, aside from the one that we're about to go visit, which no longer exists. It was a race. Basically, whoever was the first to make a nuclear weapon obviously was going to win the war. The Americans decided that they wanted to start producing heavy water to do research with. They ended up using graphite as a moderator. So the whole thing with nuclear technology, any kind of radiation, is uranium, all these radioactive substances. Ultimately, what makes them radioactive is they have too many protons and neutrons in their core. And so they're trying to equalize themselves by shooting out protons and neutrons at everybody, basically. That's what radioactivity is. But normally, when there's no moderator, so a moderator is what in nuclear physics, it's what they use to slow the fission reaction of the uranium down so that it can cause a chain reaction so that you can get a proper nuclear reaction. So water doesn't do anything. Water actually absorbs radiation quite effectively, and they use water as along with concrete, lead, and various other substances, as a barrier to protect from radiation. But for some reason, heavy water, which is known as heavy hydrogen, which has a neutron, and it's water that has a neutron in its nucleus, it has a higher boiling point, and it also slows the atoms down to the point where they can achieve a chain reaction. So this heavy water plant in Norway, this is what the Nazis were trying to do. And at the time, it was new technology. There was a select group of physicists from the world's leading universities that knew what it was. The guy Selwyn Blaylock, the guy who ran the mine, who ran the smelter, he was initially not sure if there was a market for producing heavy water after the war, after the atomic weapon had been made. And the thing is that they hadn't realized he could use it for nuclear power. He was apprehensive to use it because basically he wasn't sure if there was going to be a good market for it. But he ended up being wrong. This is the tech fertilizer area / assay office / so there's a pipeline that goes from the smelter that we toured this morning to here. And this is where they assay the samples. I have these little zinc pucks that I'll show you. These were assayed here, and you can see the facility over there. So the heavy water tower they built, Project 9 it was called, was somewhere over here. So we're driving towards the billboard right now. It's the Cominco Heavy Water Plant. At the time, it was Canadian Consolidated Mining and Smelting Company. 1942, guys, this was happening. And at the time, everybody in the plant and in the community was sworn to secrecy. They actually had defensive weapons here. They had a truck that was armored and had machine guns on it. They called it Seabiscuit. It was responsible for the defenses of the entire area because basically had the Germans and the Japanese found out about this area and what was going on here, they would have taken every precaution possible to sabotage it. So basically, this allowed the Americans to conduct research into nuclear fission, which allowed them to produce the atomic bomb. Now, they used graphite as a moderator because it ended up being a more effective moderator than heavy water, because they could, for nuclear weapons and stuff, easier to control. But what the heavy water did do, and they supplied heavy water to the United States well into the 50s, was it gave the United States the ability to produce power, right? So it's a big deal, guys. Oh, it's over there. It's over there. I could really dig for this one. Like, really dig. I spent hours trying to find the coordinates. I found this one obscure page on the internet that actually had it. Probably some guy like me. There's the billboard of the tower, picture of the tower too. Alrighty guys, so we're here at the site of the Project 9. So here we go. Let's give her a whirl. So this would have been the tower. This is the Kamenko Heavy Water Tower. This is what they were using. I'm going to explain how they were separating the heavy water, but this is it, guys. This is the building. This is the building that started it all here. In the midst of World War II, Churchill recognized the importance and perseverance to the success of the war effort. The people of Trail also recognized this factor and answered the call of duty in many ways. Guys, this was a really, really important part of history that has not been reported properly. So, upon the outbreak of war in 1939, the government of Canada conscripted virtually the entire medical and chemical production of the Consolidated Mining and Smelting Company of Canada. Also set metal prices at low levels and continuously demanded more as World War II continued. The company's fertilizer plants began to make explosive-grade nitrates, and the shops were asked to produce marine engines for the Navy. The Brilliant Dam, located near Castlegar, was assigned to the government wartime work, and 2,500 of the company's employees went into military service, making it difficult to satisfy the government's needs. With patriotic feelings fueling the home front spirit, Selwyn J. Blaylock, the company's president, strove to fill the ensuing labor vacuum in order to expand the plants and sustain production. He managed this by taking the now historic and then unusual step of hiring women. In 1942, the demand of the governments of Canada and the United States, the very secret plant known only as Project 9 was built at this complex. The Allies had recently discovered that Germany had ample quantities of uranium and heavy water. That was what was happening in the Telemark region in Norway. Two components recognized by Albert Einstein as requirements for harnessing the potential of nuclear energy at its disposal. It was quickly decided that the fastest way of producing mass amounts of heavy water needed for the American Manhattan Project would make use of the existing hydrogen plant in Trail. The company's contract with the Atomic Energy Commission concluded at the end of 1955, and Project 9 was shut down, but this was the place, guys. Project 9. Many of the CSMN workforce went off to serve in the war. The women were hired to fill their places. There's the women there working. Electrolytic cells, that's what they were using to create heavy water. We're going to talk about that. The mysterious tower built in 1942 was later revealed to be Project 9. It was here that the heavy water needed for nuclear fission was produced, making Trail an integral part of the race to develop atomic weapons. So the plant right behind me, guys, where you see, right? This whole thing right here, this is the beginnings of nuclear technology, because you have to understand the Nazis were chasing the same thing, right? But they were sabotaged by the Allies and the Norwegian Resistance Force through Operation Grouse. And then even after the two sabotage attempts, they did air raids after, because the Germans rebuilt the electrolysis plant, electrolysis chambers. And after the bombing raids, the Germans took all the heavy water they could from the plant that they had. The SS Hydro, it was the ferry across the lake there in Norway. They've put it on the ferry, and the ferry got sunk by the Allies and the Norwegian resistance, and a couple of the Norwegians living in the region didn't approve of it, obviously, so they helped sabotage the ferry. And so the drums of heavy water have sunk to the bottom of the lake, and because it's heavy water actually sinks. So as you can see, right, power very important. So the whole reason that they were able to produce heavy water through electrolysis is because they had access to electricity. The plant in Norway had access to electricity, and the Trail plant here for smelting, because they were using electricity for their smelting. So you see here how it's like this tower. This is a big deal, man. It's a super big deal. Hello.
Can I help you?
Oh, I'm just getting this on camera.
Okay. Okay, that you can, yeah.
Oh no, yeah, I know, I understand, sir.
You know
I did the trail smelting tour this morning.
Oh, okay.
Yeah. So I'm just getting the billboard and just getting a pan of like the area. No, I know I can't film any of this. I'm all aware.
Okay.
Yeah, no, I don't.
Just so you know.
Yeah. No worries, man. It's all good. So once Leif Tronstad had fled Norway, he brought the dossier to London, where they figured out about the Nazis' plan and how they were making heavy water the Telemark region at the Norsk Hydro Dam. So they launched Operation Grouse, which was a group of guys that deployed into the Hardanger Plateau in Norway
once they were on the plateau.
And they were supposed to be followed in by a bunch of planes, but the planes crashed and everybody on the planes died, and the people that didn't die on the plane in the plane crashes were sent to concentration camps and killed. So they failed, but these 4 guys were held up in the bush over the winter, living off lichen and moss, living in like a cave at the side of the mountain, because they knew they had a job to do, and they knew how important it was, because if the Nazis got enough heavy water, they'd create a nuclear weapon and they'd drop it on England, and that would have been, I don't need to tell you guys what that would have been like, right? So the British and the Norwegian resistance knew this. They knew that these 4 guys had survived because they weren't involved in the plane crash. And so they sent another group of guys to rendezvous with them, and then they skied to the site. And then once they got to the site, where everything was guarded, it was all blocked off, they couldn't get access. But the Germans made a critical error. They didn't protect the rail line because they thought, oh, we don't have to guard the tracks, right? It's just for the train. So they cut down into a ravine and scaled up the ravine and walked right into the plant through the railway tracks. Then they rappelled in through the basement window because they had to destroy the electrolysis chambers, because that was the process of electrolysis was how the Nazis were creating heavy water, and is also what they were doing here. But they didn't want the Nazis having it, because obviously the world would have looked a lot different had the Nazis gotten it. They were found out by a Norwegian janitor, but because Norway was occupied by the Nazis, he was sympathetic to them and the fact that some of the guys were Norwegians as well. So he helped them. He didn't report them. He was just a janitor in the hydro plant. So he helped them. And then they left the Thompson machine gun behind because they didn't want the Nazis to go and kill all the locals that lived in the Telemark region, because they thought, like, it was Norwegian resistance that did this, so we're just going to go and, kill everybody. So the British and the Norwegians specifically left a Thompson gun in plain sight, so that when the Nazis were inquiring about who did this, they would find out that it was the British from the Thompson gun, and it would save the small Norwegian communities from basically being exterminated by the Nazis. So they blew the plant up. It was all good for a little bit, but then the Nazis rebuilt it, because the Nazis they understood the importance of it. They knew what they were getting here. Then the British had to do a series of air raids. So then they dropped a whole bunch of bombs. They dropped over 400 bombs. They killed a whole bunch of innocent bystanders. People's homes were obliterated in the blast. But they met their target. Most of the bombs didn't hit, but it only takes a couple, right? And so they hit their target, and it was destroyed. So then the Germans realized, okay, they're onto us. We gotta bail. So they took the remaining heavy water that they had stockpiled, loaded it onto the SS Hydro, which was the ferry that the dam company was using to transport people and supplies, everything like that. And so it was a joint effort between the Norwegian resistance, the Norwegians, just like the people of Norway, and the British to basically stop this ferry. Because if they didn't stop this ferry, and they were pretty much certain that the Nazis would have gotten the proper amount of heavy water they needed to make a nuclear weapon. And like I said, I do not need to really tell you what that was happening. So on the same side of that, so you have what's happened in the Telemark region, Norwegian resistance, the bombings, all of that, the SS Hydro, and this is from 42. In 42, this happened. At the same time, in 1942, the Americans were working in conjunction with the Canadians at the place that we just were to basically produce heavy water, so that the Americans, because the Americans initially thought they were going to use heavy water for their nuclear weapon. They ended up using graphite because Oppenheimer, their famous doctor that created the thing, he decided that graphite was a better moderator, that had more control or whatever, yield a more severe reaction, right? So they ended up using graphite, but they had to be pure graphite, because if it had if it had boron in it, it would get absorbed and it wouldn't work. So they used the heavy water that they got from the Canadians to do research into nuclear fission and how it works. And in 47, the first heavy water-based nuclear reactor in the entire world was built by the Americans in Chicago. It was called Chicago Pile 3. But it allowed the Americans to understand the chain reaction and fission and how the nuclear reaction worked. It was still really important that they had heavy water, because they ended up using heavy water to make nuclear power. And in Canada, we're a world leader in nuclear power and heavy water technology. But the takeaway from this, guys, is that had the Trail smelter not existed, the history of the world could look much, much different, and I don't think it's a reality that any of us, except for a small few of us, would want to ever imagine. There's a lot of history here. A lot of it's not known. I don't know if it's because the Americans don't want you to know, or it's like a dirty little secret, but American historians, for the most part, don't really acknowledge it. Frankly, even Canadian historians don't. I was in at the Trail Interpretive Center. There's no reference to any of this. They don't, in their timeline history, they skip right over 1942. They go from like 42 to 43. So because it's Canada, basically, you know, we're painted as a peaceful, amazing country, which we are, but we helped create the atomic bomb. Had we not been producing heavy water for them, the atomic bomb would not exist. The Americans also had heavy water plants. They had 3 heavy water plants in the States, but they were inefficient and they used a completely different process of boiling. The plants were brutal. They shut down, had problems all the time. So the American plants never amounted to much. The Americans tried to produce heavy water and they failed, but they still needed heavy water to do their research. So then they leaned on the Canadians, basically. And then there was a fight afterwards. Britain and America were racing for nuclear supremacy, basically, in the world now, because whoever has nuclear power and nuclear weapons is superior, right, technologically. So the States, Canada and Britain sided with each other, and the States got pissed off, and so they withheld all their, like, all the stuff that the guys at Princeton and Harvard, like all the physics these guys knew, they were withholding all this information from the British and the Canadians. So they had to kind of, like, you know, it was a whole thing, because they were basically, the Americans wanted to be the ones that were first. They had the first nuclear power reactor, they had the first atomic weapon. Like, it's very, very typical of America, right? I know that a lot of Americans watch this, but it's just, you know, it's history, guys. This is what it is, right? Look right ahead of you there, guys. You see the big panorama of the smelter. See the whole plant from up here. Oh, you can see the whole building. Yeah. So the plant is divided into 2 sections. We went and saw the zinc plant. The electrolytic plant is right there. That's the electrolysis cells. Those are the vent stacks that I was telling you about. And the sulfur feed goes up to the plant, the fertilizer plant for that, but the lead stuff is on the other side, but they don't typically. Oh, here we go. The pipeline. This is the pipeline. This is the fertilizer pipeline. So they send their sulfur that they extract out of the from the stack process, and they send that up the tech operations there at Warfield to produce fertilizer. But this is that whole thing you see there. That's all the electrolytic plant. That's where they use cathode plates, aluminum cathode plates, to get the zinc. But the lead is on the other side. So the plant's divided into 2 sides. The lead on the one side and the zinc on the other. But you can't really, they don't take you in to do the lead, because lead is very toxic, obviously. If you didn't know that, you do now. So they don't want, obviously, people that don't have to be exposed to lead, you know, walking through the lead smelter getting a tour. So the lead part's off limits. That's, you know, that's even the guys that work in the electrolytic plant for zinc don't necessarily go over to the lead plant. And then those sulfuric acid boilers there, like those conversion towers, that's where they harness the sulfur, basically. They harness the sulfuric acid, the sulfur, and then they pump it up to that pipeline there.
So we're going to talk about electrolysis. What is electrolysis? Electrolysis, lysis, means to break, right? Break down. So basically, electrolysis is the breaking down of a material, be it water, anything, right? Through electricity. So what they're doing with electrolysis is they're basically employing DC current through an electrolyte of water, acid water, salt water, water with some kind of electrolyte in it, which then creates a non-spontaneous reaction that allows for the breakdown. In the case of water, you have H2O, and then you have a little bit of heavy water. So what they're doing basically with electrolysis is they're separating the hydrogen and the oxygen and leaving behind deuterium. Now the Americans used a boiling point method where they've just boiled water. They boiled water, and the boiling point of heavy water is higher than normal water. So the idea was that you boil off all the water and relieve by the heavy water, but they still had to treat it with electrolytic process to fully refine it. So we're going to talk about how the Canadians did it. So Dr. Hugh Taylor, he visited the Trail plant and talked to Selwyn Blaylock, who was a McGill University in Canada metallurgist. They both knew about heavy water. He wanted the Canadians to produce heavy water for them. So he came up with a system of catalysts to basically refine, to enrich the heavy water more so. So what happened was they had 4 towers, enrichment towers they called it. They would have hydrogen gas in the towers. They would push the water up into the towers, enrich the water, and have a catalyst in there. And a catalyst is something that creates a non-spontaneous reaction while itself not changing, right? Catalysts would be catalytic converter, air filters, activated carbon in diving air racks. So basically, the first 3 towers were platinum on carbon catalysts, catalytic converter basically, and this allowed for the enrichment of the normal water. It was then passed through a nickel chromia catalyst, which was the final stage. Then it was sent to the electrolysis area, where they would then do electrolysis in the cells, then refine it down to heavy water by basically removing the hydrogen and oxygen from it. And that electrolytic cell works on non-spontaneous reaction. A galvanic cell is basically a battery. So you have same thing, you have anode and cathode, but instead of it running a non-spontaneous reaction, it's a spontaneous reaction. So the electrolyte that's in the battery just reacts automatically and causes a small amount of power to be produced, which then is a battery basically. The galvanic cell and the electrolytic cell are similar, but they work off 2 different reactions. And in this case, with electrolysis, we're using the non-spontaneous reaction to distill out heavy water, which basically just has an extra neutron, which makes it more dense, and it's heavy water, right? D2O, deuterium oxide, basically. That's kind of in a nutshell how electrolysis works and how they were distilling heavy water at the plant. There was patent issues with the hydrogen cells, the electrolysis cells that they were going to use, and they had to do all that stuff, but it was Dr. Hugh Taylor's design of the catalysts and the combined with the already known electrolysis system they had in place, that they basically they got a whole bunch of money from the US government. They built up the facility even more and made it just basically more productive because they needed to have certain amounts of heavy water. Now in the end, they didn't end up using it. Like I said, they used graphite, but it laid the foundation for a lot of research in nuclear power.
So we're going to finish the show here for now.
That's going to bring us to a close here on the Project 9, Kaminko Heavy Water Project, Manhattan Project, secret project on top of Manhattan Project, and the Norwegian Heavy Water Sabotage. Whew, that's a lot. So anyways, guys, I really hope you enjoyed the history and the kind of adventure, frankly, on this one. Seeing the Kaminko Heavy Water Tower, just seeing a place in history that was super important to the world. Basically set the world into a new age of technology, and say what you will about nuclear weapons, but it allowed the world to have nuclear technology with heavy water, and there was a lot of good benefit. It was really, really interesting. That's going to be it for me. I hope you enjoyed it, and Sasquatch Prospector out.